Hello everyone, welcome to the second session of bridge course on physics. I think those who probably missed the yesterday's session, you can take a look at the recorded video. It's available on our Concept Digital portal as well as in the YouTube channel also it is available. You can take a look at it. So this is in fact like an continuation to what is the discussion we had yesterday. So in fact the first and second sessions, right, we wanted to dedicate for one of the important ideas in physics, which is the vectors. So guys, you know, those who have been there in the yesterday's session, right, you know that we have covered about the basic understanding of what is a vector, how do we represent vectors, and what is a scalar, what is the difference between a vector and scalar. And when we're talking about the difference between vector and scalar, right, we kept on saying one thing, that vectors will have magnitude. So what are the things that the vectors will have? They will have magnitude, plus they will be associated with a direction. Not only these two, they also satisfy an addition law which we call as the vector law of addition. So what is the law that they satisfy? Vector law of addition. Scalars, they can be just given by the magnitude. So we can express the scalar quantities by just magnitude. Like, you know, I want to tell temperature value to somebody. What I can say? I can say that the temperature today is 25 degrees centigrade. That's it. The information is complete. By just giving the value of it, the information will be complete. Whereas if I have to talk about, say for example, displacement, I have to talk about what is the displacement value. If I say that it is 5 meters, it is not complete. I have to also give what is the direction. Is it 5 meters towards the right side, or 5 meters towards the left side, or 5 meters towards east? What is the direction? I have to express the direction also. So that is the basic difference between vectors and scalars. But we said there is the other part of the vector definition, which is vectors must satisfy the vector law of addition. So the way they are added should not be like the way we are adding numbers. So they will not be added like the scalars or numbers. They will be added in a different method, and that is what we are going to be learning today. So we are going to be learning what is this vector law of addition, how we are going to find the resultant of vectors. So we cannot add, like say for example, if you have a mass of 2 kg and mass of 3 kg, straight away what we say, total mass will be 5 kg. The same thing cannot be said about the vectors. So if there is a force of say 2 newtons and another force of 3 newtons acting, the total force will not be always equal to 5 newtons. It will be 5 newtons in some cases. It depends upon the orientation or angle between the vectors. So the resultant of the force will depend upon what? Orientation or angle between the vectors. So all of this we are going to learn in this session, guys. So let's get into it. So for this session, right, we don't need to have much of an background. Just that we should know a vector will be represented as what? Line segment, and vector will have a direction. And how do we mention angle between two vectors? That is also important. So how do we mention angle between two vectors? If we have two vectors which are expressed with same starting point, you know what we call them as co-initial vectors. If we represent two vectors like this is vector 1, this is vector 2. The smallest of the angle, we can see they will be forming here how many angles? 2 angles they are going to form, alpha and beta. So smaller one, alpha will be smaller one. Smaller one will be taken as what? Angle between two vectors. So we must know the idea of angle between two vectors, and we must know that the vector will be having magnitude and direction. That's it. So with these ideas we can go on with this session, guys. So in this session what we are going to learn? We are going to learn about how do we find the resultant of two vectors, and also we'll see how do we find resultant of many vectors also. So this is a more detailed discussion, and as yesterday class also I told that almost half of the chapters in physics, right, you will be relying upon the idea of vectors or the application of vectors. So if we are clear with these concepts, means we will be able to really do well in all those chapters. Okay guys, so we'll just get started. So what is this vector law of addition? Vector law of addition is a law. So we'll see what is this law also. But we have two methods of understanding the law. Both will give us the same final result. The final result will not be different. They are not going to give us two different results. Both of them, they are going to give the same final result. But we will give the statement of the law in two different methods. It's like this, we are going to get the same final result. Either you come like this or you come like this. Doesn't matter. The result will be always same. So what are these two laws? One is the triangle law of vector addition. Second is called as what? Parallelogram law of vector addition. So just again guys, what are the two laws that are there? One is called as what? Triangle law of addition. Second is called as what? Parallelogram law of addition. Okay. Now we'll start with what is the first one. What is the first one guys? Triangle law of addition. Now while we are discussing about these laws, right, if you have any doubt, you can just type it in the chat box. I'll be able to quickly clarify that. And even if I'm not able to, because if all of you are chatting in that, then I might not be able to see all the questions. But if I miss some of the questions, right, I will definitely make sure that after the session I'll again come back and clarify. Okay guys. So if there is a very glaringly some kind of an doubt, or you are not able to just grasp an important concept, then make sure that you keep typing it at least twice or thrice if I miss on that, so that I'll be able to definitely answer that, because without that you might not be able to proceed on with the next part of the lecture. Clear guys? So these are the general guidelines I want to keep, so that you guys will be engaged. I mean, it is not like a recorded lecture, it is like a live session. So as you guys are going through the class, right, so if you have any doubts or something, better that we clarify it then and there. Okay. So guys, let's get on to it. What is it? Triangle law of addition. What is this triangle law of addition? So I'll first read the statement, then I'll explain it. Okay. So what is the statement of the triangle law of addition? If, you can probably read along with me, if two vectors are represented in magnitude and direction by the two sides of a triangle taken in same order. So what is the statement guys? Again, I think it is visible. If two vectors are represented in magnitude and direction. How they are represented in magnitude and direction? By the two sides of triangle taken in same order. I'll show what that means. Then the resultant is given both in magnitude and direction. The resultant value will be given both in terms of the magnitude and direction by the side of the triangle taken in opposite order. So a triangle will have how many sides? 3 sides. So if we are representing, let us say there is a vector a bar, and taken in order means like this. Wherever the first vector is ending, second vector is going to start from there. This is the vector b bar. So what do you mean by taken in order guys? Remember, when we are representing a vector by a line segment, right, the length of the line segment will be representing what? The vector magnitude. So longer vector means the magnitude of the vector is higher. Shorter means the magnitude will be what? Lesser. Okay. So if you have two vectors taken in order as the sides of the triangle, then the other side taken in opposite order means, see, if you come like this, come back like this, means that is in order. No, we should not come in order. We should come in opposite order. So the third side of the triangle taken in opposite order, that is going to give the resultant of the two vectors. So I am indicating resultant with what? Symbol R bar. So R bar will be what guys? Resultant of A bar and B bar means what? A bar plus B bar. Now you can see that the value of the resultant, which is given by the length of this line segment, right, it will depend upon what is the length of A, will depend upon what is the length of B, and also depends upon what is the orientation. So the resultant depends upon what factors guys? It will depend upon length of A, means what? The vector A magnitude. I can indicate this with symbol what? A. It will depend upon vector B magnitude. And the orientation between vectors. Orientation is given by what guys? Angle between the vectors. Okay. So That is how the resultant of the two vectors is given as per the triangle law of addition. Okay guys, so just summarize it one more time. If we are having the two vectors taken as the sides of triangle in same order, then the third side of the triangle in opposite order, third side of the triangle in opposite order will be giving what? It will be giving us the resultant. Okay, and we can see that the resultant value will depend upon what? It will depend upon the first vector magnitude, second vector magnitude, and also it will be depending upon the orientation or angle between the vectors. So this is what is the triangle of vector addition, guys. Now what we'll do is we will take a look at the second law. What is second law? We said second law is the parallelogram law. Now once we cover the parallelogram law, right, you will see that both of them are going to communicate the same thing. So both triangle law and parallelogram law are going to give us the same final result. They are not going to give us two different results. The final result is going to be always same. The statement only will be different. The approach will be different. So what is this parallelogram law? Read the statement along with me, guys. If two non-zero vectors are represented, so we are first of all taking what? Non-zero vectors, means they should not be null vectors. A zero vector can be also called as what, guys? Null vector. We have covered this in the yesterday's session. If two non-zero vectors are represented by the two adjacent sides of a parallelogram, then the resultant is given by the diagonal of the parallelogram passing through the point of intersection of the two sides. So what is this? If we have, say for example, this is the first vector A bar and this is the second vector B bar. These are the adjacent sides of the parallelogram. If this is the case, we can complete the parallelogram. So parallelogram, you remember the property of parallelogram, guys? What is the property of the parallelogram? Opposite sides will be parallel and opposite sides will be equal. In a parallelogram, opposite sides will be parallel and opposite sides will be equal. Okay, now look at this. If we have a parallelogram, then the two adjacent sides of the parallelogram, this is A and this is B, these are the adjacent sides. So they have the same common starting point. So can we say that they are co-initial? Yes, we can say that these two vectors are what? Co-initial. Then the diagonal starting from the same point of intersection, like we have to have a diagonal from here, this will be giving us the resultant of the two vectors. So this diagonal is going to give us what? Resultant of the two vectors A bar and B bar. Clear, guys? This is what is the parallelogram law. Now what I said, both triangle law and parallelogram law, they are not different. We said they are basically giving us the same result. How? If we try to see this, again I will draw the same parallelogram. Look at this, guys. This is B bar, this is A bar. So complete the parallelogram. If this is, and where is the resultant, guys? We said this is the resultant, correct? If this is B bar, the parallel side to it will be same in terms of length, and if you choose the direction also same, this is B bar, means this vector also will be what? B bar, because if there are two vectors having the same length and same direction, we will call them as what? Equal vectors. So this is B bar, means this also will be what? B bar. Now you see one thing interesting, that here A bar and this B bar, they both are what? They both are, like, you know, if you look at this triangle, let me mark the corners as what? 1, 2, 3. In this triangle 1, 2, 3, right? I'm just giving the number so that we can easily visualize it. Triangle 1, 2, 3. Look at this, guys, carefully. This is A bar and this is B bar. So how we are writing them? They are written as what? The two sides of the triangle taken in same order. Wherever A bar is ending, B bar is starting. Okay. Then the third side. What is third side, guys? This 1, 2, 3. This is what? This is the third side. In reverse order is going to give us what? Resultant. That is what is the triangle law, right? So parallelogram law and triangle law, they are going to give us the same final result. They are not going to give us two different values. Okay. So this is how we are going to find the resultant of two vectors. Okay, guys, any doubts? If you are clear with this idea, means we will proceed on to the next concept. Now we understood how do we get the resultant value geometrically, okay, but it is not possible to keep on drawing the vectors. I mean, every time we will not have a scale and a paper to draw a bar and draw b bar and then get the resultant by using the triangle law or parallelogram law. We must be having a formula where if we know the magnitudes of the two vectors, if we know probably the angle between them, then we should have a formula to get what is the resultant value of the two vectors. We should have a formula to get what is the resultant magnitude. So we are going to do the derivation. We are going to do the derivation for what? Resultant of the two vectors. So if you are clear with these two laws, means we will go for the resultant. But before we go to the resultant, right, we will be using trigonometric ratios. Remember guys, in 10th standard, right, we have studied about the trigonometric ratios. Now I know this is math, but we do require it in physics also. So what are these trigonometric ratios? If we have a right angle triangle, so trigonometric ratios we define for what guys? Right angle triangle. We have base, we have let's say this is theta, this is the angle here, and we have the opposite. You can also call it as height. Base can be also called as what guys? Adjacent side. And this is the hypotenuse. Clear guys? So for this right angle triangle, right, we will be defining the trigonometric ratios. What are the trigonometric ratios that we know guys? Sin theta. What is sin theta? Opposite side by, guys, we know these things, correct or not? Opposite side by hypotenuse. What is cos theta? Cos theta will be what? Cosine. Cos theta will be what? Adjacent side by hypotenuse. Then we have tan theta. What is tan theta guys? Opposite side by adjacent side. 1 by sin theta will be called as what? Cosecant theta. 1 by cos theta will be called as what? Secant theta. 1 by tan theta will be called as what guys? Cot theta. So these are some of the trigonometric ratios that we already know of. So we know sin theta, we know cos theta, we know tan theta. 1 by sin theta will be called as what? Cosecant theta. 1 by cos theta will be called as what guys? Secant theta. And what about 1 by tan theta? 1 by tan theta will be called as cot theta. So what we will be looking in this particular derivation is, we are going to be using the idea of sine and cos. We will be using the sine and cos functions. Now if you look at some of the standard angles, what do you mean by standard angles guys? Like 0, 30, 45, 60, 90, all of them we will call as what? Some standard angles. And by the way guys, this is angle in degrees and we have angle in radians. Both these things we must be comfortable. So 30 degrees means what is the value in radians? Pi by 6. So angle in radian, this is the conversion, right guys? Angle in radian will be equal to what? Pi by 180 into angle in degree, because 180 degrees will be equal to what? Pi radians. So this is the formula for converting angle in degrees to radians. Check this guys, if you are not aware of this means you can just make a note of it. Okay, so 30 means what? Pi by 6 it comes. 45 means how much it comes? Pi by 4 it comes. 60 means how much it comes? You can just check it. So pi by 180 into 60. 61s are 63s are. How much it is going to be guys? Pi by 3 it will come. Okay. So 60 means what? Pi by 3. 90 means how much it is guys? Pi by 2. So cos 0 will be 1. Sin 0 will be 0. Cos 30 will be what guys? Root 3 by 2. Sin 30 will be what? Half. Cos 45 and sin 45, both of them, either we can say root 2 by 2 or we can say what? 1 by root 2, whichever you want to use. Okay. Now cos 60 will be what guys? Half. Sin 60, root 3 by 2. Cos 90 will be what? 0 and sin 90 will be what? 1. So these are some of the standard trigonometric ratios and the values. So while solving problems, especially in physics, mostly we will be using these common trigonometric ratios. And if you remember the sine value and cos value, we can tell what is the tan value, because what will be the tan value? Tan will be always sine by cos. So we take the sine value, we take the cos value, and we'll divide sine by cos. What we are going to get? We are going to get the tan value. Clear, guys? So these are some of the common trigonometric ratios that we will use. Sometimes what happens is we may not have the common trigonometric ratio values. In that case, we will be using some trigonometric relations. So whenever we are not having the common trigonometric ratios, we will be using some trigonometric relations. What are these trigonometric relations? So these trigonometric relations will actually help us. They will help us in finding the value of trigonometric ratio from the known ratios. Like, sine of 90 minus theta. Theta will be here angle, guys. Will be equal to cos theta. Similarly, if you have cos of 90 minus theta, it is going to be equal to sine theta. So what is it, guys? Sine of 90 minus theta will be what? Cos theta. Cos of 90 minus theta will be what? Sine theta. Sine of 90 plus theta will be cos theta. Remember, guys, in 10th we would have learnt sine is positive in first and second quadrant. Sine is negative in third and fourth quadrant. This is the first quadrant, the second, third, fourth. Cos is positive in first and fourth quadrant. Cos is negative in second and third quadrants. So sine of 90 plus theta will be what? Cos theta. Cos of 90 plus theta will be minus sine theta. Then sine of 180 minus theta will be sine theta. Cos of 180 minus theta will be minus cos theta. So remember, guys, these useful conversions. So they will help us to find the value of any other trigonometric ratio if we know some standard trigonometric ratios. I'll show you one quick example. Let us say we want to find cos 120. We know cos 30, cos 60, cos 45, cos 90. We have not talked about cos 120. See how I am going to write it. I will write cos 120 as what? Cos of 180 minus 60. See this, guys? Cos of 180 minus theta. What is cos of 180 minus theta? Minus cos theta. So what is the value, guys? Minus cos 60. Means what? Cos 120 value, because cos 60 is what? Half. So minus is there. So cos 120 value will be equal to what, guys? Minus half. Like that we can get the value of some other trigonometric ratio from the known values. Generally known values means we will remember for the standard angles like 0, 35, 0, 30, 45, 60 and 90. Using them we will be able to find for some other trigonometric ratios also if we use these conversions. Clear, guys? Now with this understanding, right, we will go and take a look at the derivation. This is an important derivation, guys. Even in your regular school exams, etc., you will be having this derivation. We'll take a look at the derivation for getting of the resultant. So here in this derivation, right, what we are going to choose is we are going to choose two vectors a bar and b bar with an angle theta between them. And as per the triangle law, how do we represent the two vectors? Let us say a bar is like this. B bar will be starting from wherever the a bar is ending. This is b bar. This is a bar, this is b bar. And what is the angle between the two vectors? Theta is the angle between the two vectors. So how do we represent theta? Remember what we talked about the angle, guys? For representing angle, the vectors should be arranged as co-initial vectors. Here wherever the a bar is ending, b bar is starting. So here a bar and b bar in this representation, right? This representation A bar and B bar are not co-initial vectors. So wherever the A bar is ending, B bar is starting. So what we will do is just look at it closely. We will extend this line. When we extend this line, we can see, if we think about A bar to be like this, remember yesterday class we discussed, this movement of vector is called as what? Translation. We can just move the vector A bar like this. Then we can see now A bar and B bar are what? Co-initial. So if theta is the angle between them, where is theta going to come? Theta is going to be coming over here. Clear, guys? Now let us say the resultant is given by what? Closing side of the triangle in opposite order. This is resultant. And let alpha be the angle that resultant is making with A bar vector. Resultant is having some orientation, right? So let us say alpha is the angle made by the resultant with the A bar vector. And A, B and R, they represent the magnitudes of A, magnitude of B and magnitude of the resultant. Now in the derivation, right, what we are going to find is, we will find what is the value of R. We will find what is the value of the resultant magnitude. And also we will find what is the value of alpha. So alpha gives us what? It gives us what is the orientation of the resultant vector. So alpha gives us what is the orientation of the resultant vector. So the derivation, we are going to find what is the value of R and what is the value of alpha. So what we'll do is, we'll just redraw the diagram in a little bit more clearer manner. So we have the A bar over here and this is B bar, guys. When we extend the line, we can see the angle theta will be formed over here. Clear? And from this tip, from the tip B, we drop a perpendicular. This we are doing for the derivation purpose. We drop a perpendicular. Perpendicular is coming and joining where? N. Okay, guys? Now the angle that R bar is making with A bar is what? Alpha. The starting point is what? O. So what we are going to find here? We are going to find the R value and we are going to find the alpha value. Now where is R? If you see R is coming as the hypotenuse in the right angle triangle OBN. You can see that O, B and N. This is the right angle triangle. In this, R is hypotenuse. So to find the value of R, whenever we talk about a right angle triangle, guys, what is the first thing that will come to our mind? Pythagoras theorem. So we think that we can use Pythagoras theorem to get the value of R, because that is the hypotenuse. Remember what is Pythagoras theorem? Hypotenuse square is equal to base square plus height square. But we should know what is the total base, means we should know what is ON, total base, and we should know what is BN. We should know what is ON and what is BN. ON and BN values we will get by first choosing the small right angle triangle. Look at this, guys. We have a small right angle triangle. You know what is small right angle triangle here I am talking about? ABN. ABN. That is a small right angle triangle. In this small right angle triangle, you know what is the hypotenuse here? B is the hypotenuse. What is the angle here? Theta. Look at this small right angle triangle. Look at this small right angle triangle. What is the hypotenuse? B. So here sin theta will be what, guys? Opposite. Bn by hypotenuse is what? B. Means Bn is equal to what? B sin theta. This is B sin theta. So Bn value will be what, guys? B sin theta. And cos theta. Cos theta will be what, guys? Base by hypotenuse. Means An will be equal to what, guys? B cos theta. So this is B cos theta. Now the bigger right angle triangle OBN that we are talking about here, right? The OBN, what is the base value for the OBN right angle triangle, guys? Base will be what, you know? OA plus AN, that is ON. Means what? Base will be A plus B cos theta. Just work it out along with me, guys, so that you will be comfortable. What is the base and what is the height? Height is same. For smaller right angle triangle and bigger right angle triangle, the height is same. Height is what, guys? B sin theta. And what is the relation we have in Pythagoras theorem? Hypotenuse square, R square is equal to what? base square. What is the base value, guys? A plus b cos theta the whole square plus b sin theta the square. Okay, so what we'll be having, this is like x plus y the whole square. What is the formula, guys? X square plus y square plus 2 into x into y plus b sin theta square means what, guys? B square sin square theta. Now look at these two terms, guys. B square cos square theta plus b square sin square theta. Why I am marking those two is, if you take b square common out, what we'll have? Cos square theta plus sin square theta. What is cos square theta plus sin square theta value, guys? Always 1. So what we have is r square is equal to what, guys? A square plus b square plus 2ab cos theta. So the final value of the resultant, right, will be what? R will be root of a square plus b square plus 2ab cos theta. That is the value of the resultant. Okay, guys. So whenever we have two vectors a and b with an angle theta between them, what is the value of the resultant of the two vectors? Root of a square plus b square plus 2ab cos theta. Now we are also seeing one more result here. What is it, guys? Alpha value. So look at this bigger right angle triangle. What is tan alpha? Opposite. Opposite is what, guys? B sin theta by base. What is the overall base? A plus b cos theta. So we know what is the resultant value and what is the angle made by the resultant with vector A. What is the value of the angle? Tan alpha is given by what? B sin theta by A plus b cos theta. Again, look at this, guys, how it is coming in the bigger right angle triangle that we are seeing, right? In the bigger right angle triangle, this is b sin theta. What is the overall base? A plus b cos theta. So this is alpha. So tan alpha will be what, guys? B sin theta by A plus b cos theta. So this is what we have as the derivations in the resultant formula. So we have the resultant value. What is the resultant value, guys? Root of, this formula is very, very important. Root of a square plus b square plus 2ab cos theta. Means the resultant value is depending upon the vector A magnitude, it is depending upon the vector B magnitude, and it is depending upon the angle between the vectors. And the orientation of the resultant is given by the angle that it is making with vector A. If alpha is that angle, right, then what is the relation we are having? Tan alpha will be equal to what, guys? B sin theta by A plus b cos theta. So maybe this is the first time you are seeing the formula, so it will take some time for you to absorb this concept, but you just make a note of it while we solve problems, right? I mean, that is how any new concept will get imbibed. So any new formula or new concept we see, right, don't worry if you are not able to grasp it in one go. Make a note of it, and as we keep working it out, right, more problems that we work out, we will be able to absorb that concept better. We'll have different ideas of testing that particular concept. It will check how well we understand it, and thereby our clarity on the concept also will improve. That is why we keep on saying, do practice, do follow practice whenever you go through a topic or you go through a new idea. Okay, guys, so what we'll do is we will go and solve some sample problems. Now we have the formula, let's go and solve some sample problems. Two vectors have magnitudes 8 and 6 units. What are the vector magnitudes, guys? 8 and 6 units. These are the vector magnitudes. If the angle between the two vectors is 60 degrees. What is the angle between the two vectors, guys? It is given as 60 degrees. Find the resultant value. We need to find what is the resultant. So it's a straight formula question, guys. Let us say the two vectors are what? A is 8. B is what? 6. What is the angle between them? 60 degrees. What is the resultant formula, guys? R is equal to what? Root of a square plus b square plus 2ab cos theta. Do we know a value? Yes. Do we know b value? Yes. Theta is 60. Means what will be cos 60 value? What is cos 60, guys? Half. So can you put it in the formula and tell me what is the final answer coming as? So what we do, guys? Root of 8 square plus 6 square plus 2 into 8 into 6 into cos 60 is what? Half. So 2 is cancelled. So root of 8 square is what? 64. 6 square is what? 36. 8 6 are 48. Root 148. Check it up, guys. What should be the answer for this? Root of 148. Yes. Some of you are telling the answer correctly. The answer will be what? Root 148. So this is the idea, guys. Whenever we have two vectors, right? If we are given the magnitudes, see how simple it is. If we are given the magnitudes, if we know the angle, all that we need is what? Cos theta. What is the formula for the resultant? Root of a square plus b square plus 2ab cos theta. Now let us do one more sample question, guys. This I want you guys to work it out and tell me. Two forces acting on a body have magnitudes 4 Newton and 3 Newton. What are the magnitude values, guys? 4 Newton and 3 Newton. If they are at right angles, two vectors which are at right angles, right, guys, we also call them as what, by the way, orthogonal vectors. What is the other name we can use for this, guys? Orthogonal vectors. Means what? The angle theta will be 90. What is the angle between them, guys? Theta will be 90. What we need to find in this question? What is the net force or the resultant force? We need to find the net force or the resultant force. So the resultant can be also called by the name net. Both are same thing. Again, straight formula question, guys. What is the R formula? Root of a square plus b square plus 2ab cos theta. Here theta is 90. Means what is the cos 90 value? Cos 90 is what, guys? 0. So cos 90 0 means, look at this. Here we'll get cos 90, right? So this entire 2ab cos theta term will become what? 0. It is going to simply become 0. So this is a standard formula, guys. If two vectors are perpendicular, or two vectors are orthogonal, or two vectors are making angles 90, right angles, in all the cases, what is the resultant formula? Simplified value R will be equal to what, guys? Root of a square plus b square, because the 2ab cos theta term will become 0. Why it is becoming 0? Since cos 90 is 0. Okay. Now come to the question. What are the two vector magnitudes, guys? 4 Newton and 3 Newton. So what we have, let us say a is 4. We can give any value. No specification. B is what? 3 Newtons. You can give a also 3. No problem with that. B also can be given as what? 4 Newton. I think somebody is already asking it. Which one we should take which value? We can take it whatever you want. Okay. So we can take a is 4, b is 3. Or we can take b is 4 and a is 3. Okay, guys. So essentially what we have is root of 4 square plus 3 square. What is it, guys? 4 square is how much? 16. 3 square is what? 9. Root 25, it is 5 Newtons. So in this case, the resultant of the two vectors is what, guys? 5 Newtons. Clear? Now remember, in the beginning of the discussion, right, even in our lower grades, we hear this. If there are two vectors A and B, when they are in the same direction, what is the total resultant value, guys? A plus B. When they are in opposite directions, what is the resultant value? Either A minus B or B minus A. Basically higher value minus lower value, like that. We will see how those results are actually coming, because everything has to come from this formula only. If I have two vectors A and B parallel, parallel means what, guys? Theta will be what? 0. So what is the resultant formula? Root of a square plus b square plus 2ab cos theta. What is cos 0, guys? Cos 0 is what? 1. Remember, we saw that in the table. Cos 0 is what? 1. So means 1. So what is a square plus b square plus 2ab, guys? A plus b the whole square. So root of 4 square will be what? 4. Root of 5 square is what? 5. So root of a plus b whole square is what, guys? A plus b. So if you have two vectors parallel, what is the resultant going to be, guys? A plus b will be the resultant. Okay, we simply have to add them. So means if I have, say for example, 10 Newton, another 2 Newton, same direction, means what is the resultant force? 10 plus 2, it is going to be 12. Simple. Okay, guys. Now let us see the next one. What is the next one? Two vectors A and B anti-parallel, means opposite directions. Means angle will be what, guys? 180. If one vector is like this, other is going to be like this. What is the angle here between them, guys? 180 is the angle between them. Okay. Then the resultant magnitude is, look at this, guys. This symbol is called as what? Whenever we put two vertical lines for any number, this is called as modulus. What we call it as, guys? A modulus. Modulus of any number, right? Like say modulus of -4 will be 4. Modulus of 2 will be 2. Modulus gives us the absolute value, means without negative sign. Modulus gives us absolute value. So why are we putting modulus? I'll tell you. We always will take the positive value, means either we'll take it as a minus b if a is higher, or b minus a which if b is higher, like that. So how this comes? Look at the resultant formula, guys. A square plus b square plus 2ab. What is cos theta? Cos 180. What is cos 180, guys? Cos 180 is -1. What is cos 180? -1. So what we have? R is equal to root of a square plus b square minus 2ab comes, which is what, guys? Root of a minus b the whole square, means we have to take either b minus a or a minus b, whichever is higher, minus lower value. So this is about the resultant of two anti-parallel. And the last one, if two vectors a and b are perpendicular, just now we saw in the previous question, what will be the resultant, guys? Root of a square plus b square, because why? The cos 90 is going to become here 0. That's why what is the resultant value? Root of a square plus b square. So just to summarize these things, guys, if two vectors are parallel, what is the resultant? Simply a plus b. Like in this problem we are seeing, right? If we have two forces, 10 and 2 Newton, means what is the resultant? Same direction, means the resultant is what, guys? 10 plus 2, 12. Two vectors anti-parallel. Then the resultant will be what, guys? A minus b. Means if we have, say, one direction 10 newtons, other direction 3 newtons, opposite direction, what is the resultant? Higher value minus lower value. 10 minus 3 is what, guys? 7 newtons. Two vectors are perpendicular, means what is the resultant formula? Root of a square plus b square. So take care of these formulas, guys. Just make a note of it, because these are very important. These are the things that we are going to continue from the first chapter kinematics in +1 till the last chapter in +2. So these vector ideas we have to carry on from the beginning till the end. Now the addition of two vectors we saw. Numbers, right? Numbers, what we say, we will talk about addition, we will also talk about subtraction. We will say 5 plus 2 is there, 5 minus 2 is there. But what about the subtraction of vectors? How do we see subtraction of vectors? If we are doing subtraction, right, a bar minus b bar like this, subtraction is taken as a special case of addition. How do we take subtraction, guys? It is taken as a special case of addition. How? We will take it as the adding of minus b bar to a bar. Just one, if we have a minus b, we can also take it as what? As if we are adding minus b bar to a bar. So in vectors, subtraction also we are going to consider as what, guys? It is considered as a special addition case. So the subtraction, there is nothing called as subtraction. Subtraction also will be taken as what? Special case of addition. So how we are going to do this a bar minus b bar? Look at this, guys. If we have a bar like this and this is b bar, this is theta. What is minus b bar? A vector equal value, exactly opposite direction will be minus b bar. So this is minus b bar. If the angle between a bar and b bar is theta, what is the angle between a bar and minus b bar? 180 minus theta. And modulus if a bar is a, means what is modulus of minus b bar? B only, because b bar and minus b bar will have the same magnitude. And what is the angle between a bar and minus b bar, guys? 180 minus theta. So we will see the resultant formula. Root of a square plus b square plus 2ab. Here what is the angle between a bar and minus b bar? Cos 180 minus theta. Remember, guys, we have seen the formula. What is cos 180 minus theta? minus cos theta. Cos 180 minus theta is what? Minus cos theta. So I can call it as r dash or something. So a bar minus b bar value will be what, guys? Root of a square plus b square minus 2ab cos theta will come. What will be the value of a bar minus b bar? Root of a square plus b square minus 2ab cos theta. Understand how we are getting it, guys? We are saying it is not like subtraction, it is also like addition. What we are saying? We are adding minus b bar to a bar. Okay, that is fine. So means b bar and a bar are there. Let us say theta is the angle between them. What will be minus b bar? Vector exactly same magnitude but opposite direction. This is minus b bar. Now we can see if theta is angle between a bar and b bar, what is the angle between a bar and minus b bar going to be? This angle, which is going to be 180 minus theta, because angle on a line is what, guys? 180. Okay. Now what is the magnitude of a bar? A. What is the magnitude of minus b bar? B only, because b bar and minus b bar, they will have the same length. Means if b bar is 4 Newton force, right, minus b bar also will be 4 Newtons. If this is east, means that will be west. Only the difference will be in terms of direction. Okay. So the resultant formula will be what? Root of the first vector magnitude square plus second vector magnitude square plus 2 into first vector magnitude into second vector magnitude into cos of angle between them. Here what is the angle between a bar and minus b bar vectors, guys? 180 minus theta. So we have cos 180 minus theta, and cos 180 minus theta is what? Minus cos theta. So thereby what is the total value of the resultant between a bar and minus b bar? This is the resultant of a bar and minus b bar. What is the resultant, guys? Root of a square plus b square minus 2ab cos theta. So this one we can use as a result to find out the value of a bar minus b bar. So we have two formulas, right? What is the formula for a bar plus b bar? Resultant root of a square plus b square plus 2ab cos theta. Then we have the formula for the resultant of a bar minus b bar. What is it, guys? Root of a square plus b square minus 2ab cos theta. Then we have this idea called as Polygon Law. Polygon Law is nothing but extension. This is what we said, right, guys? How do we find the resultant of many vectors? This is extension of triangle law. What is the Polygon Law, guys? Extension of triangle law. What is this extension of triangle law? If you look at the triangle law, what is triangle law? If two vectors are taken as the sides of triangle in order, then the resultant is given by what, guys? Third side in opposite order. That is the triangle law of vector addition. Polygon law will be just extension of this. Read this statement, guys. If number of non-zero vectors are represented by the n minus 1 sides of n-sided polygon. The polygon must be having how many sides, guys? N sides. In that, n minus 1 means if you have a polygon of 7 sides, 6 sides must be represented by what? The non-zero vectors which are in order, means same way. Like look at this, guys. A bar, wherever a bar is ending, b bar is starting. B bar, then c bar starts, then d bar, then e bar. So like this we are indicating how many vectors? 1, 2, 3, 4 and 5. 5 sides are there here. Now the nth side, the last side basically, of the polygon in reverse order or opposite order. Just like the way in this case of triangle is what? 2 sides we take in order. Third side in the opposite order is what? Resultant. Here the resultant is what? The last side in opposite order. Like in this case, from O we have to draw the vector to E. This is the resultant. So this is the Polygon Law of vector addition. This when do you use, guys? When we have to find the resultant of many vectors. So this is what we will be using for finding the resultant of many vectors. So what is the law called as, guys? Polygon Law of vector addition. This is nothing but an extension. So triangle law, we are just dragging it to get the Polygon Law. Now while solving problems, especially in NEET and JEE or competitive examinations like even BITSAT, etc., we have these numerical techniques, like the techniques that we use to solve problems. And one such numerical technique that is there in vectors is the uniform distribution of equal vectors. What is this uniform distribution of equal vectors? Let us say I have a body. Two forces are acting, 5 Newton, 5 Newton. Exactly in opposite direction. Means if two vectors are there, how do we uniformly distribute them in such a way that both are making an angle 180 with each other? Then we saw in this case what will be the resultant. Since they are in opposite direction, what is the resultant, guys? 5 minus 5 is going to be what? 0. Similarly, if we have three forces, and remember guys, the three forces must be what? Equal. 5 newtons, 5 newtons, 5 newtons. If they are uniformly distributed, means the angle between each of them is what? 120, 121, because the total angle should be what, guys? 360. Then the resultant in this case also is going to be what, guys? 0. Like this, if we have equal vectors and we uniformly distribute them, then the resultant of them is going to be what, guys? 0. If we have, say for example, 5 equal vectors, we uniformly distribute them. Uniformly distributing means what? Each of them, the angle is going to be 360 by 5, because the total angle is 360 by 5 will be what, guys? 72. Between each of them, angle will be what? 72. If we uniformly distribute them, the resultant of the vectors is going to be what, guys? 0. This is also what we will be calling as the symmetry principle. What do we call it as, guys? Symmetry principle. So just make a note of it. What is symmetry principle? If we have equal vectors and we uniformly distribute the equal vectors, then the total value of the equal vectors or the resultant of them is going to be what, guys? 0. This is what we call as the symmetry principle. And there is one more numerical technique, guys, that we use for solving problems involving vectors. That is called as Lamys Theorem. It's a very popular theorem. What is the theorem called as, guys? Lamys Theorem. So we'll talk about Lamys Theorem, but before we talk about the Lamys Theorem, right, let us look at this idea. What is the idea, guys? What is the resultant of three vectors forming a triangle in order? Means, let us say we have three vectors, A bar, B bar and C bar are what? Three vectors. They are forming a triangle in order. Means what? A bar is like this, B bar is like this, and C bar is coming like this. They are forming a triangle in order. Then we are asking what is the value of A plus B plus C? What is the resultant of A plus B plus C? So guys, if you look at this, right, first two vectors A plus B, if we are taking the resultant of A bar and B bar, what is the resultant of A bar and B bar? So here remember, guys, A bar, B bar and C bar are in order. So wherever the A is ending, B is starting. Wherever the B is ending, C is starting, like this. If you look at A bar and B bar resultant, so this is A bar, this is B bar. Okay, guys? The resultant of A bar and B bar is what? The third side in opposite order. What is the resultant, guys? Third side in opposite order. Means, if you look at this, the resultant of A bar and B bar is nothing but minus C bar. Why am I saying minus C bar? If C bar is towards this side, a vector with same length in opposite direction will be called as what, guys? Minus C bar. So A bar plus B bar is giving us what, guys? Minus C bar. Means, if I am adding A plus B plus C, means it is just like what? I am adding minus C to C. So the resultant is what? 0. So if three vectors, they are forming a triangle in order, then the resultant of the three vectors is going to be what, guys? 0. The resultant of them is going to be 0. And based upon this idea only, we have the theorem called as Lamys Theorem. What is theorem, guys? Lamys Theorem. So it is an important theorem that we use in solving problems. With this, we will wind up the session, because we will try to look at the other, because since vectors is an application oriented topic, right, guys? I mean, we can have whatever the depth of applications we want, but I mean, since this is just an introductory class or a bridge course, we will try to stop it with the Lamys Theorem. So Lamys Theorem is basically, if three vectors if three vectors can be arranged in space as co-initial vectors like this, let us say this is A bar, this is B bar, and this is C bar. These are the co-initial vectors. And let us say the angle opposite to A is what? Alpha. The angle opposite to B is what? Beta. Angle opposite to C is what? Gamma. So alpha, beta, gamma are what, guys? Angles. And we know one thing. What is it? Alpha plus beta plus gamma will be what, guys? 360. Alpha plus beta plus gamma is going to be what? 360, because the total angle at a point is what? 360. Let's look at the Lamys theorem. If the vector A by the sine alpha value is equal to vector B by sine beta value is equal to vector C value by sine gamma, if this is satisfied, if this particular relation is satisfied, then A bar, B bar and C bar, right, they can form a triangle in order. And just now we saw, if they are able to form a triangle in order, what will be the outcome of this, guys? A plus B plus C, the resultant of them is going to be what? 0. If you are taking the resultant of A bar plus B bar plus C bar, what will be the overall value of that? It is going to be 0. So this is what we have as the Lamys theorem. So clear, guys, what is the Lamys theorem? If we are arranging three vectors like this, A bar, B bar and C bar, in such a way that the vector A value by sine alpha, alpha is what? Angle opposite to A bar. If this is equal to the vector B magnitude by sine beta, beta is the angle opposite to B bar vector. If this is equal to vector C magnitude by sine gamma, what is gamma? The angle opposite to the vector C. If that is satisfied, A by sine alpha is equal to B by sine beta is equal to C by sine gamma. If this is satisfied, then what happens? The A bar and B bar and C bar, they will be forming a triangle. If they form a triangle, means the resultant of them, A plus B plus C, is going to be what, guys? 0. So this is what is the Lamys theorem. And you know, Lamys theorem is also something that we will use while solving problems in vectors. So clear, guys? So this is broadly what we wanted to cover as the introduction to the idea of vectors. So we have spent 2 sessions on this, and take time to go through these concepts again. And if you would like to get more in-depth understanding of vectors, you can probably go and register for free trial of our JEE or NEET course on the Concept Digital portal. You will find the entire lecture series on vectors and applications of vectors. So in the next session, which is tomorrow, we will talk about how the concepts that we have learnt in 10th standard, like the concept of say circuits, or the concept of lens and prism, or the concept of reflection and refraction, how those concepts will be extended when we look at it from a higher level, which is the +1 +2 level point of view. So what we'll do is we'll try to take some sample concepts that we already covered in 10th and see how those concepts will come enlarged manner in +1 +2 level. Okay guys, so all the very best, have a good day. Thank you.